Everyone, and welcome to today's online tutorial where our focus is on surface area of cones. Please kindly subscribe to our YouTube channel, Prof. Tutorials, and check previous video on volume of cones for better understanding. Our focus today is surface area of cones. How do we find the surface area of cones? What are cones? A typical example of a cone that we can find around us is an ice cream biscuit part. Now, there's the biscuit part of an ice cream. Now, in this ice cream, we can see this circular section, okay, and this slant side. Okay, so a cone is made up of two parts, the circular section, which we often call the base, okay, and the side, which we refer to as lateral, or the curved surface, the curved part. Briefly, I'm going to take you through the curved part first, okay, because to be able to find the surface area of this cone, we need to find the area of all the surfaces. So which is, we have two surfaces, we have the circular part and we have the side or the lateral part. Okay, so for this two, let's take an illustration from a circle. We have a circle and this is the center point of the circle. We can have, remember, the radius is from the center to a point on the circle. And let's say we also have this from the center to a point on the circle. Okay, so this is a curved part. So this part is referred to as sector of a circle. So let's say this is sector of a circle. So this sector of a circle is like what you have here. Okay, so we have the slant length L, which is this, and the circumference C of the circle. To find the area of a sector, it is simply A equals 1 over 2 times the slant length, which is this L, times the circumference, the arc length, so which is C. So this area gives us 1 over 2 times the slant length times, check previous video on how to find the circumference of a circle. We established that the circumference of a circle is 2 per half. Okay, so from these points we can have these two cancel out these two, then we are left with the area equals L times pi times r, which we can write as pi RL. Please take note of this. This is the area of the side of the cone, which is this two. Okay, and we will call the area of a circle, which is pi r squared. So if you have some examples, it can ask you to find the lateral area, which is also this side, or the curved surface area of the cone. You use pi RL. But if you are looking for the total surface area of the cone, it's going to be the area of all the surfaces. So we have the lateral side, which is pi RL, plus the circular part, which is pi r squared. This is the total surface area of a cone. That is what we have here. I've explained all that area of all the surfaces, the base, which is the circle, and the side, which is the lateral area. And its surface area is lateral area plus area of the base. I established this for you by RL, and the area of the circle per r squared. Okay, and finally, with this formula, you can simplify further as pi r is in both sides, so we have pi r into bracket. We are left with L plus 1R from here. So this is the formula for finding the surface area of a cone. Let's take a look at an example for better understanding. This is an ice cream cone. The figure shows an ice cream and find its lateral area. Don't forget, we have just established that the lateral area of the cone, which is the area of the side, okay, of the side of the cone, is pi RL. And this gives pi times the radius of the cone. The figure given here is 10. This 10 stands for the diameter of the cone, okay? So diameter of the cone is 10 centimeter, and we remember that to find the radius, it is simply diameter over 2. So that means the radius value which we need is 10 over 2, which gives 5 centimeter. Substitute the right value. So this gives 5, not 10, times. This is the slant length. The slant length of the cone. Remember, we have this, the slant length of the cone. So the slant length of the cone is given as 12 centimeter. And finally, you can have your final answer to be pi times 5 times 12, which is 60 pi, and that gives 188.49. 188.49. Let me quickly explain something here. In case you have an exam question and says, find the lateral area of the cone and give your answer to the nearest tenth. To the nearest tenth. Now, what do you mean by tenth? Of course, it means after your decimal point, just the next value after your decimal point. So to the nearest tenth. To get the right value that will be here, you need to consider the next value. Now, the next value here is 9. If the next value is greater than 5, that is more than 5, it turns to 1 and you add the 1 to the 10th value. So in this case, 9 is greater than 5, so it turns to 1, then we add it to the previous value. So this gives 188.5 centimeter, the lateral area of the cone. How do you find its surface area? Simply, we have the surface area of the cone, which we've already established in the formula. All you need to know, you remember the formula, okay? So that is pi r into L plus r, the radius. And by substituting, you have your pi times the radius 5 into the lateral, the slant length, which is given as 12, okay, plus the radius 5. And this gives, using your calculator, you have pi times 5 into bracket 12 plus 5, which gives 85 pi. This is your answer in terms of pi, okay? But in terms of decimal, you have 267.0. 267.0 centimeter squared. I beg your pardon, this is squared. It's as simple as that. Okay, we look at another example. Here you have to be very careful because I'm going to be showing you the difference between slant length or height and the actual height of the cone. Okay, let's look at this example too. Of course, this is a cone. In this cone, we have the height, which is the straight path from the apex of the cone to the center point of the circle. The height is given and the radius of the circle is given. Remember, from this point here to this point here is the slant length, which is what we need in our formula. The question says find the surface area of the cone. What is the surface area of a cone? Remember the formula? This is it, okay? So we have the pi times the radius into brackets slant length plus radius. Slant length, not height. So this takes us to another part in mathematics. If you look at this part, let me call this A, the center B, and this is C. Bringing out that, you see a triangle, okay? This is a triangle. This is the A, point B, and this is point C. Okay, looking at this is the radius, which is here 3 meter, and this is the height AB, which is 4 meter. So it means that you need to get the slant height or the slant length, this L part, to be able to use in the formula. So to find this slant length, we use what we call Pythagoras Theorem in mathematics. And Pythagoras Theorem states that the square of the side facing the right angle, which is this, the square of the side facing the right angle, which is L, its square, is equals to the sum square of the remaining two sides, which is AB and BC. So AB is 4, so it's squared, plus BC, which is 3, it's squared, okay? So this gives us 4 squared, which is 4 times 4, 16, plus 3 squared, which means 3 times 3, and that is 9. This gives us 25. So your L squared equals 25. We need the value of L, not L squared. And in mathematics, to be able to achieve this square coming to this other side becomes square root, okay, of 25. Square root of 25 means what number will you multiply 2 times to get 25? If you use your calculator as well, you get 5. So the slant length is 5. Therefore, having done that, you have your surface area to be equals to pi times the radius r, which is 3, into the slant length, which we've gotten as 5, plus the radius 3. And with this, you can get your final answer. With the use of calculator, I can have my pi times 3 into bracket 5 plus 3. And this is your final answer. 24 pi. In terms of pi, the surface area is 24 pi meter squared, as you may have in some objective questions. If it's given in terms of decimal, remember, I can just press this and get the value out, 75.39. So I have 75.39 meter squared. To the nearest tenth, like I explained earlier, one value after the decimal point, consider the number next, 9. 9 is a number greater than 5. Therefore, it turns to 1. Add 1 to this 3. It becomes 75.4 meter squared. And that is how to find the surface area of a cone. I wish you all the best. I will say again and again, to become a mathematics giant, you have to solve more examples. Don't run away from problems. Don't run away from questions. When you see the question, settle down in your mind to solve the problem. If you solve, you get it, then you get better. Thank you and see you in our next video. Remember, subscribe. Prof. Dan Tutorials. Bye bye.